This video will provide guidance on guaranteeing qualified picking accuracy during project deployment. In the video Picking Accuracy Overview, we have learned about the 4 sources affecting picking accuracy and the specific factors they cover. Now let's begin to look at the key components through deployment processes. One thing to note is that imprecise picking issues are inevitable. Therefore, the picking accuracy just has to meet the site requirements. During the process of designing the vision solution, please confirm the accuracy requirements on site. For higher accuracy, it's necessary to pay attention to the system drift. Minimize its impact by the warm-up preparation and stable environmental temperature. Meanwhile, the system drift autocorrection solution can be used. It not only avoids the temperature drift of the camera, but also ensures reliable and stable operation of the 3D vision system. This is helpful for long-time picking with high accuracy. Entering the setup of the vision system hardware, first, check the robot. Securely mount the robot base and make sure there's no wobble in the robot body. Check the robot absolute accuracy. For this, check the 0 positions for their accuracy. If they are inaccurate, please recalibrate. Move the robot a certain distance along a fixed direction in the workstation. Measure the actual movement distance. Compare it with the distance displayed on the teach pendant. A smaller difference means a higher robot accuracy. When the absolute accuracy cannot meet the site requirements, please contact the robot manufacturer. Besides, if a 7-axis robot is used, to check its accuracy, move it a certain distance repeatedly. Verify the robot model in the software matches the actual robot. To confirm alignment, synchronize joint positions from the teach pendant to Mech-Viz. Check if the robot flange pose in the software aligns with the actual robot flange pose. If not, refer to the documentation to troubleshoot this issue step by step, and modify the model parameters accordingly. Then, check the gripper. Make sure to rigidly mount it. Verify the gripper TCP accuracy. Rotate the robot end around the pinpoint in different directions. Check the distance fluctuation range between the robot end and pinpoint. If there are obvious deviations during the rotation, calibrate the TCP. Please refer to the manuals of each robot brand for calibration. After confirming that the TCP accuracy is correct, record a fixed point for future periodic checks. Next, check the camera. Ensure a steady camera mounting frame with no shaking. If a sliding device is involved, ensure its accurate repeatability. Confirm the point cloud quality. Ensure the workpiece is in the camera's field of view. Check the impact of ambient light on the workpiece point cloud. When the impact is significant, shade the light in the workstation. Then, adjust the camera's 3D exposure parameters for a complete workpiece point cloud. Continue to confirm the camera intrinsic parameters. They are meticulously checked at the factory, thus usually accurate. Use the intrinsic parameter tool in Mech-Eye Viewer for check. If the check fails, handle the problem as prompted. If the problem remains after handling, please contact technical support engineers. For the process of hand-eye calibration, the extrinsic parameters will affect the picking accuracy. Therefore, the following should be noted to improve the accuracy. Stabilize the calibration board when the robot reaches the calibration path point to capture images. If the robot carries a heavy gripper, enable the robot payload compensation and complete the calibration with the gripper. Upon configuring the vision project, if deep learning is used, ensure a good recognition quality. Many factors will affect the deep learning recognition, so please refer to the appropriate tutorials and documentation for improvements. When making the point cloud model, choose a reasonable way to make it and ensure a correct pick point. Next, Check the pose repeatability by statistics. Fix the camera and workpiece. Use the camera to capture 10 to 20 images at the same position to count the pose statistics. Observe the statistics to evaluate if the repeatability is feasible according to the requirements. If not, adjust the point cloud or reselect a suitable model to optimize. For higher accuracy, place the same workpiece in different areas and heights to count the pose statistics. Make sure the repeatability meets the requirements based on the statistics. Last, during the phase of picking, pay attention to the recognition stability. Ensure the stable recognition of all the incoming situations for workpieces at the workstation. In case of any instability, the parameters or even the recognition strategy need to be adjusted. Moreover, confirm the stability of pose adjustment strategies. For this, the strategy should be applied to all the incoming situations of workpieces at the current workstation. The above are all important components in the project deployment process. If there is any inaccuracy in the process, you can also use the error analysis tool to quickly troubleshoot. During the actual production, picking errors are inevitable. Please check all components orderly shown in the video. This will help the final robot picking accuracy to meet the site requirements. For more detailed operation, please refer to the documentation at the bottom of the video.